In this video, I'm going to teach you how to write the equation of a polynomial function when given its graph. So you'll notice on the screen there's a graph of a polynomial function in blue, and off to the side in red are the directions which say to write the equation of p of x using the smallest powers possible. So my strategy for doing a problem like this is to read the graph from left to right and first make sure I know where each x-intercept is. Now I've gone ahead and labeled those for you, and the first one is -5. And I ask myself the question, if -5 is an x-intercept, what factor could it have come from? So if I'm thinking backwards in trying to find x-intercepts, I know I'm supposed to set factors equal to 0. So if the answer is -5, it must have come from a factor of x plus 5. So there's this connection that the number that I write as a factor is opposite in sign from the actual 0. So that's something to keep in mind. The next 0 is -2. So I think, well, what factor did that come from? Well, the opposite of -2 is +2, so I'm going to write down x plus 2. The third 0 is at 1. So the factor which gives me 1 as a 0 must be x minus 1. The fourth 0 is 3, coming from the factor x minus 3. And finally, our fifth 0 is 6, and that came from the factor x minus 6. So step 1 for me is to look at each 0 and write down the corresponding factor, and I've done that. The next thing I consider are the multiplicities, the pass-throughs, the bounces, and the wiggles, and how they're going to affect the powers of each of these exponents. The first x-intercept, -5, appears to be a pass-through, and a pass-through means that this factor is going to have a power of 1. The 0 at -2 appears to be doing a wiggle. A wiggle is any odd power other than 1. So I could use 3, 5, 7, 9, etc., except that the directions say to use the smallest power possible when there's a choice. So I'm going to use 3 since that's the smallest odd number not equal to 1. The next 0 is 1, and that appears to be bouncing. So bouncing could be any even number, 2, 4, 6, 8, but since we're using the smallest one, I'm going to use 2. The next 0 has another bounce, I'll use 2 again. And the final 0 looks to be wiggling again, so I'm going to use 3. So from the zeros, I was able to get the factors. From the bounce, pass through, and wiggle, I was able to get the powers. But the one thing that's missing, the one thing I haven't really addressed yet, is the y-intercept. This is going to play a role as well. And what I like to tell my students is to take that y-intercept and write it as an ordered pair. So instead of thinking of this as just 216, I'm going to think of it as 0, 216. And what that means is when x is 0, y must be 216. So to include this into the equation, I'm going to put a c out in front. That c stands for constant. And numbers in front of functions give vertical stretches or compressions. And I'm going to be able to solve for c by plugging in 0 for x and 216 for y. When I plug those values into what I just wrote, I'm going to be able to solve for c, and that's going to give me the appropriate vertical stretch or compression, and I'll be done. So I'm going to go ahead and make those substitutions, starting with replacing y with 216. And now I'll replace each occurrence of x with 0, leaving me with 5 to the first, or 5, 2 cubed, or 8, -1 squared, or 1, -3 squared, or 9, and -6 cubed, which is -216. The equation that I have resulting only has one variable, so to get c by itself, I'm just going to divide the 216 by all those numbers. Now, luckily, since I have a 216 over here and over here, they're going to divide out, and I'm just going to be left with the number 1. So I'm going to go ahead and I'm going to write c equals. Now these are going to cancel, the 216 and the 216, although I am left with this negative, which it's important, so I'm going to put that in front so as not to forget it. And now I have 1 on the top and -360 on the bottom, because 5 times 8 is 40, 40 times 9 is 360. So now that I know what c is, I can rewrite the problem putting that in for c. So my final answer is y is equal to negative 1 over 360, and then all of these factors here just repeated. So there you have it. Here is the equation of the polynomial function shown in blue.